Okay, welcome back to this the last part of our systems of linear equations and inequalities review. Our last part is going to be on systems of linear inequalities here, and there's no better way to get started than to get started. So let's go ahead and do that. We have two inequalities up there in the top left. We have x is greater than -5 and y is less than -2. Let's work with x is greater than -5. Well, when we go to graph that, we know that it's going to be a vertical line that's going to cross at -5, going to cross the x-axis at -5. So let me go ahead and get that lined up for you. And so it has to cross at -5. There's -1, -2, -3, -4, -5. So it's crossing right there. Now, is it going to be a solid or a dashed line? It's going to be a dashed line because it does not have the equal to sign with it. All right, now, x is greater than 5. Let's pick a test point. We can pick the test point of 0, 0. 0, 0, so x is 0. Plug that in for x. There's the x value. We don't have a y value, so we don't have to worry about that one. So 0 greater than 5, it's -5, and that's going to change our answer choice there. Is 0 greater than -5? Is 0 greater than -5? Yes, it is. So we shade everything at the same side as 0, 0. Our second equation, y is less than -2. Okay, well, if y is less than -2, it's going to be a horizontal line that crosses at -2. So there's -1, there's -2. It crosses the y-axis at -2. Now we need to pick another test point. We can go ahead and use the same test point, 0, 0. And in this case, the y is 0. So 0 less than -2. Is 0 less than -2? No, it's not. So 0, 0 is not a solution to this one. So we shade everything below. And where do they intersect? Where do they cross? It is this section here. That's the overlapping parts. And that is the graph of the system of linear inequalities of x is greater than -5 and y is less than -2. So look at the next one here. We have some of these here. Let's look at the top one. 2x minus y, or I'm sorry, 2x minus 10y is greater than 8. We need to go ahead and graph that. So we say 2x minus 10y is, and since we're graphing, I'm going to put an equal sign there. We just have to deal with whether it's solid or dashed and which side of the line do we shade when we work with that inequality. So if we look here, I know they all can reduce by 2, right? So that cancels. We're left with x minus 10 over 2 is 5 equals 8 over 2 is 4. So x minus 5y is equal to 4. Let's find the x-intercept. So y is 0, so that's x minus 5 times 0 is equal to 4. Those cancel, so x is equal to 4. That's 4, 0. So we go ahead and plot that point. 1, 2, 3, 4, 0. And I believe from here, we're going to use the slope And I'm doing that because I know that if I want to find the y-intercept is going to be, I'm looking at that, it's going to be negative 4/5, and that's not a real easy one to put on the graph, exactly on the graph, because it falls between 0 and 1. But I'm going to go ahead and find the slope, and to find the slope, subtract x from both sides, so we're get left with negative 5y, and this is where I'm at. Negative 5y is equal to negative x, and that's a positive 4. Divide both sides by negative 5, and that's everything by negative 5. So y is equal to a negative divided by negative makes a positive, and we put the x out to the side, so then we have the invisible 1 on top. That becomes visible. And now if we have a positive 4 divided by a negative 5, it's going to be a negative 4/5. And so this is what we're looking for. We're looking for that slope. The slope is 1/5. So if I have a point, I can, if I have a point that's on the line, I can use that slope from that point and graph the line. And I do have a point right here. I have the 4, 0. So let's go a slope of 1/5 from there, which means we go up 1 and to the right 5. 1, 2, 3, 4, 5. I could have also gone down 1 and to the left 5 and plotted the point. And now we need to look up here back at the original equation. Is it going to be a solid or a dashed line? It's going to be a solid line. Or I'm sorry, I got those confused on another lesson at 1.2. It's going to be a dashed line because it says it does not have the or equal to sign with it. So this is where we're at, and this is what you have. All right, now we need to pick a test point. We can go with 0, 0. So I'm plugging 0, 0 in there. I know 2 times 0 is 0, minus 10 times 0 is 0, and then is that greater than 8? So is 0 greater than 8? I don't think 0 is greater than 8, so we have to shade on the opposite side of the line. Okay, so that's what we have. That's the first part. Got the first line graph. Now let's go ahead and work on the second line. X minus 5y is less than 12. X minus 5y is less than 12. I'm looking at this. I'm trying to figure out a good method of graphing this. Tough. It's real tough. Because I know the y-intercept is not going to be an exact number, but then I also know that the x-intercept is at 12, which is off the charts. So I'm going to go ahead and graph that or find that x-intercept, I think. If I can do this. You might want to, if you have paper at home, see, I'm trying to get these to be, this is a little bit confusing, right? Give me 1 second here. See how I put those grids on top of each other, and now I know that this is 11, this is 12, and this is 13, and that allows, and I have those equally spaced apart. That's the whole goal, is to get those equally spaced apart. Now see, I'm deleting that, and I'm able to get that x-intercept of 12. I'm able to get that figured out. Let me bring this back real quick and go ahead and draw that y-intercept up through there. All right. So there we go. And you can do that by putting another sheet of graph paper underneath yours and tracing it or there's a few other ways that you could do that. All right, so let's look here. We have this one. So like I said, we're going to find the x-intercept. So that makes 5 times 0 is 0. So x is equal to 12. So there's that is not the x-intercept. That's the y-intercept. Alrighty then. That's what happens every now and then. Sometimes you mess up, and sometimes you have to rethink some things. So follow me here. Let me go ahead and quickly get this back on the graph. And yeah, I think this will work. All right. You have a few mix-ups every now and then. And I need the x-intercept, right? So let me get this back out here. And there's 11, 12, 13, 14. Okay. Now the x-intercept would be 12, 0. So 12, 0 is out here for 12. And now, like we did previously, we can just find the slope. We can find the slope, so we subtract x from both sides. Negative 5y is equal to, what is that, negative x plus 12. Divide both sides by negative 5, so that means you divide everything by negative 5. So y is equal to negative divided by negative makes a positive. Move the x out, so you have positive 1/5 x. And for the 12 and the 5, positive divided by negative makes a negative, and you have 12 over 5. And so the slope is 1/5, so we will move the slope of 1/5. That means up 1 and to the right 5, but I don't like that because it takes us even further off the graph. So let's make both of them negative like we had it up here, negative 1 over negative 5. So that means we go down 1 and to the left 5. So down 1 to the left 5. 1, 2, 3, 4, 5. And you put a point. And then you go down 1 and to the left 5. 1, 2, 3, 4, 5. You put your other point. And if we notice here that these graphs are not going to intersect, and they don't intersect because if you notice the slopes, or both of them have a slope of 1/5. With this, if you look, is it going to be solid or dashed? It's actually going to be dashed because it does not have the or equal to with it. Let's go ahead and get these graphed here. All right, there we go. And now we have to pick a test point. For the test point here, we can use 0, 0 again. So if we plug that into the original inequality, x is 0 minus, what's 5 times 0? 0. So is 0 less than 12? Yes. Yes, it is less than 12. So it's going to be everything above that line. Is what we shade. And now what is the solution area? Where do they overlap? They're going to be overlapping at this area between those two lines. Okay, that is the overlapping section, is between those two lines. Hey, I wanted to share some things with you. I know that we've worked pretty hard. We've worked real diligently on these 3 lessons, and then so it's been tough, but I wanted to share a few quotes with you guys that'll make you think about, a little bit of working hard. One quote is by from what I looked up is by a gentleman by the name of William Barclay. He said, "Endurance is not just the ability to bear a hard thing, but to turn it into glory." And so I understand that this algebra sometimes gets tough and it gets challenging, it gets long, but remember what William said, endurance is not just the ability to bear a hard thing, but to turn it into glory. And so when you're done here, you're able to look at this and say, you know what? I've done this. I'm able to do this. This is something I've accomplished, something I can do. So therefore, you should feel good about yourself. You've turned this into some sort of glory, and realize that it's a tough, challenging concept, and there's a lot of people in the world that aren't able to do this, but you are. So keep your head held high and keep working and keep trudging along. If we look here, looking at the top inequality. If we look at the top inequality, I know that the y-intercept is going to be divided by, actually not 5. I saw 15 and thought 5. If we divide this by 3 and we divide this by 3, we're going to get 5 there. Maybe that's where I got 5 from. So the y-intercept is going to be 5, and that's a good number to graph. Now, I don't want to find intercepts here because if I find the x-intercept, it's going to be negative 15. And negative 15 is tough to graph, and we have to go through, making more grid marks down along there. It's just easier with this. It's just easier to find the slope-intercept form of that equation. So if we look here, how do we find slope-intercept form? We have to add x to both sides. So we're left with 3y is equal to x plus 15. And then we divide both sides by 3. So y is equal to 1/3 x plus 5. 15 divided by 3 is 5. So this is what we have, and we can graph this. Y-intercept is at 5, and the slope is 1/3. That means up 1 to the right 3. Up 1 to the right 3. Or down 1 to the left 3. And let's go ahead and graph it. Is it going to be a solid or a dashed line? It says or equal to, so it's going to be a solid line. And that's what we have. Now we need to know which side of the line to shade. Which side of the line are we going to shade? Can we pick a test point? I'm going with 0, 0. You can pick any point there is that's not on the line, but I always go 0, 0 because negative 0 is 0, plus 3 times 0, which is 0. Is that less than or equal to 15? 0 plus 0 is 0. So less than or equal to 15? Yeah, that's true. So it's everything here below the line. It's everything below the line because 0, 0, that test point was below the line. So the ordered pairs that fit that inequality will be below the line. Let's go ahead and do the next one. The next one only has one variable in it. So basically, if it only has one variable in it, you have to solve and get that variable by itself. And since this is x, it's going to be a vertical line that crosses the x-axis at 3. Now, vertical line crosses the x-axis at 3. So if we look, there's 1, there's 2, and there's 3. Is it going to be a solid or a dashed line? It says or equal to, so it's going to be a solid line. And that's what we have. Pick your test point. Like I told you before, 0, 0 is a good one to have. So 0, 0, x would be 0, so 0 is greater than 3. Is 0 greater than 3? No, it's not. So this point 0, 0 is not an answer. So we're going to shade the other side of the line in which 0, 0 is not on, which this would be it. And where do they overlap? They overlap here to here. Since these are solid lines, they are part of the answer. And they overlap in these areas. Throwing little swirlies there. Hope you didn't get dizzy from that, fall off your chair. It'd look awful silly. Okay. We've gone into 3. We've gone into 3 inequalities here. It's really just the same. You graph all 3 of them and find out where they overlap. It looks like I'm going to need to get me one more line on here, so let's go ahead and do that. Well, I put 2 more on there. That's okay. So what are we going to do? Let's do y is greater than -2. Y is greater than -2. So we're going to need a dashed line. So I'll go ahead and pick one of those up. And y is greater than -2. I know it's a horizontal line that crosses the y-axis at -2. So there's -1, there's -2. So which values of y are going to be greater than -2? Is 0, 0, is 0 greater than -2? Yes, it is. And so this is where we're at. The next one, x is less than 5. I know it's going to be a dashed line, so let me grab the dashed line here. Now, if x is less than 5, it's going to be a vertical line that crosses the x-axis at 5. 1, 2, 3, 4, and 5. X is less than 5, so if x is less than 5, let's go ahead and use the point 0, 0. So is 0 less than 5? 0 less than 5? Yeah, you bet 0 is less than 5. Okay. And now we have this last inequality here. X plus 2y is greater than -4. And from here, this one's easy to find the intercepts because I know if I let x be 0, that cancels out. So I'm just left with 0 plus 2y is greater than -4. So divide both sides by 2. So y is greater than -2. So y would be -2. I probably should have an equal sign there if I'm trying to graph this. Graph the line first. And then, so if I let y equals 0, so I'm going to have x plus 2 times 0, which is 0, and equal sign there, -4. So x is equal to -4. And so there I have my 2 intercepts. So let me go ahead and graph those. 0, -2 is right there, and -4, 0. 1, 2, 3, 4. It's right there. And from here, is it a solid or a dashed line? It just says greater than. It does not say greater than or equal to. So that's why we're going to make it a dashed line. And graph these. Let's see here. 2, 4, 2, 1, 2, 3, 4. I just plotted some other points on there. So that way I could get my graph extended out here. And I think it looks like that. We'll take a test point here. The test point, you got it, 0, 0. Okay, so we plug 0 in for x. We plug 0 in for y, and 2 times 0 is 0. And that's greater than -4. So 0 is greater than -4. Is that true? Yes, it is true. So 0, 0 is a solution to the inequality. So that's why we shade above the line. And check the point, where do they all overlap? Well, they overlap from here and over. That little triangle right below where I just went, they don't all overlap there. The green does not go there. The green squiggly lines don't go there. And you notice I'm not drawing it on those lines because those lines are dashed. We cannot have the points on those lines to be the answers because they don't make those inequalities true. So this is where we're at. And it does go off the graph. It is not only contained on the graph, it goes off of the graph. So let's see what we got here. Is it making sense? Is it starting to look like the answer? Step back and look at it. I think we can tell which part's the answer. I think we can tell. It's the blue part there. All right, rightio then. We're going to move right on. Here we go. If you're graphing these, you could start to pick up the pace in graphing these. Looking here at the first one, we can figure out the intercepts on this real quick. Like I said, we're plugging 0 in for x, and then we plug 0 in for y. So if we plug 0 in for x, what's y going to be? Well, you divide both sides by -1. Y is going to be 0. And, well, we can't find this right here. That is the x and the y intercept. So that is the x and the y intercept. So what are we going to do? Well, you can either change it to slope-intercept form, or you can change it to, you can just pick a value for x and solve it out for y. Let's go ahead and do that. Let's pick a value. Actually, I'm going to pick a value for y. Let's pick 5 to be y. X minus 5 is equal to 0. How do you get x by itself? You add 5 to both sides. So x is equal to 5. So x is equal to 5, y is equal to 5. Plot that. Right there. Is it a solid or a dashed line? It will be a dashed line. Now this one here, we can't pick the test point to be 0, 0 because it goes through 0, 0. So we have to pick a test point that's not 0, 0. And how about that one? That one's 5, 0, right? So x is 5, y is 0. 5 minus 0 is 5. So is 5 less than 0? 5 is not less than 0. So that test point of 5, 0 is not a solution. So you cannot have that as an answer. So it's everything on the other side of that line. Like an upside down tornado, right? All right, the second equation we're looking at. The second equation, I'll quickly find the intercepts here. If x is 0, what's y going to be? Well, y is going to be 8. If in the second one, I just tried to tap with my eraser and it erased. There's your shocker, huh? And the second one, if y is 0, what's x going to be equal to? Well, x is going to be equal to 8. So we have our intercepts. Is it solid or a dashed line? It's going to be a dashed line. And there's your intercepts, 8, 0, and 0, 8. And should look something like that. This one here, we can use 0, 0 for a test point because it does not go through 0, 0. So we plug 0, 0 in there. We're going to get 0 plus 0 is less than 8. Is that true? 0 is less than 8? Yes, it is true. So then it's all of this. All right, now we have to do the last one, which says y is greater than or equal to -4. Well, when we know that it's y is greater than or equal to, we know that that's going to be a horizontal line. And we've lucked out here. This green line that I'm moving around is solid. And since the last inequality says or equal to, we know it's a solid line. So it's a horizontal line that crosses at -4. There's -1, -2, -3, and -4. So if we look there, let's go ahead and do this. Let's go ahead and figure out which side of the line do we shade. We can use 0, 0 again because it does not lie on y is greater than or equal to -4. So in 0, 0 in that ordered pair, y value is equal to 0. So this is the inequality. We have 0 is greater than or equal to -4. Is that true? Yes, it is true. So we shade everything above. Shade everything above. And this is where we're at. We look for the part where they overlap. And it looks like they all three overlap right about, let me get the yellow marker here. Looks like they all three overlap somewhere in this area. Once again, I'm not going on those dashed lines, but I did go on the solid line down here at the bottom. I did go on that line. And if we look there, looks like it's starting to brighten up the rooms, like the sun rising on a cool mountain morning. Just brightens it all up. That would be the answer there. That's the solution to your system of linear inequalities. Okie dokie then. This one here, we can go ahead and move right along. Let's see, all that's together. Okay. So the top one, 7y is greater than -49. Get y by itself because it's the only variable in the problem. So y is greater than -7. So we graph that. That's going to be a dashed line at -7. So horizontal line that crosses the y-axis at -7. So -1, -2, -3, -4, 5, 6, and 7. So there's -7. So it says y is greater than -7. Pick the test point 0, 0. 0 is greater than -7. That is true. So that's the part we shade because 0, 0 is a solution. Let's move on to the next one. The next one there, I believe I don't want to find the y-intercept because If I make that 0, the y-intercept is going to be 14, and that's not going to be on our graph. So what I want to do is I want to change it to slope-intercept form, add 7x to both sides. That doesn't really help us out either. Add 7x to both sides, and we're going to get y is equal to 7x minus 14. So y is all by itself. Like I said, that didn't help us out because we still have to plot the y-intercept first. But what it did help us out in giving us, it did give us the slope. And we're going to need that in one moment because we're going to find the x-intercept. So you plug 0 in for y, plug 0 in for y, so then we have negative 7x is equal to negative 14 once y is 0. Divide both sides by negative 7. X is equal to 2. So we have an ordered pair there, 2, 0. That's the x-intercept. Excuse me there. And now that's the x-intercept. Now we can find the next point by using the slope of 7. Remember, 7 is a fraction of 7 over 1. So that means we go up 7 and to the right 1. 1, 2, 3, 4, 5, 6, 7, to the right 1. And we could have also went down 7. 1, 2, 3, 4, 5, 6, 7, and to the left 1. Is that a solid or a dashed line? That makes it a solid line. It says or equal to, so it's going to be solid. And we can go ahead and use this one. There we go. Which side of the line do we shade? Well, let's look at this. If we choose the point 0, 0, 7 times 0 is 0. So we have 0 plus 0 is 0. And is that greater than or equal to negative 14? Yes, it is. So 0, 0 is a solution to the inequality. So we shade everything on the same side as 0, 0. And let's look at the last equation there, or the last inequality. X plus y is less than or equal to 10. This one's easy to do if you find intercepts because you have 0 plus 10 is 10, and then you have 10 plus 0 is 10. And so those are your intercepts. Since our graph only goes to 10, those are easy ones to graph. If you're working with a graph you use quite a bit, you probably want to count and make sure that it does go to 10. And if it's a new graph, if it's a new graph, you want to count it and make sure it does go to 10. If it's one you worked with quite a bit, you should know it goes to 10. Because some graphs go to 15 and some only go to like 8. You pick a test point, 0, 0. 0 plus 0 is less than or equal to 10. Is that true? You bet. So then it's everything below. And so the overlapping part, where they all overlap, it looks like it's going to be in this section here, right? So where are the lines that cut that off? Well, right here. And then it goes down to here. And you notice I'm tracing those solid lines, but I'm going to be just above this dash line. And then now I have the outline of my area, and so now I shade. And if we look there, the blue part is going to be the solution to that system of linear inequalities. All right, this one here just has 4, but if we look, the first two are real easy to graph. We know x is greater than 0. We know those positive numbers, and y is greater than 0. We know those are positive numbers, so therefore that must be quadrant 1. So if we look here, x is greater than or equal to 0. That's going to be a horizontal line. The green line there represents y is greater than or equal to 0, kind of. Yeah, now it does. And this one, for x to be greater than or equal to 0, it has to cross the x-axis at 0. And greater than or equal to makes it a solid line. All right, so this is where we're at. For the values, let's see, x, right here, this first one, x is greater than or equal to 0. We know that these numbers out here, let's say this number is 5, 0, test point. 5, 0, x is 5, so greater than or equal to 0, yes. So that's this here. And then for the second one, y is greater than or equal to 0, so pick the test point here. Let's see, what's that, 0, 4. So y would be 4 in that case. 0, 4, so 4 is greater than or equal to 0, yes. And so then it's everything above the green line. And you notice where they are overlapping? They are overlapping at quadrant 1. So basically when you see those first two inequalities, you should only be thinking that you're working in quadrant 1. All right, the next one, this next equation right there is in slope-intercept form, or the next inequality is in slope-intercept form. The y-intercept is 8, so you can go ahead and plot that. And the slope is -1/4. Remember, the negative sign either goes with the 1 or it goes with the 4. It does not go with both of them. So -1/4, that means we go down 1 and to the right 4. Down 1 and to the right 4. Or you could have went up 1 and to the left 4. We're going to need a solid line because it says or equal to. And a test point. Test point here now, since the line does not fall in 0, 0, we can pick it. So we have substituting in for y is 0. -1/4 times 0 is 0 plus 8. 0 is greater than or equal to 8. Is that true? No, it's not true. So then 0, 0 is not a solution, and therefore everything below that line is not a solution. So that must mean everything above it is a solution. Okay. And this last equation here has an equal sign. I'm going to have to change that. I don't know what I want to change it to yet. If you give me one moment here, I think I can figure it out. Why I do that, you should be able to find the intercepts real quick. The intercepts are going to be, let's see, if this is 0, you have to divide by 2. So the intercepts is -6, 0. And then if x was 0, you would have had to divide by -3. So y would equal 4. So 0, 4. Those are your intercepts. We can go ahead and plot those. We don't need that inequality yet to plot those. 1, 2, 3, 4, 5, 6. I apologize for not having that done. I thought I did. 1, 2, 3, 4. And solid line or dashed line. We are going to make it a solid line. I do know that much. And that's what we have. So now let's go ahead and figure out what inequality we're going to write there. We're going to write let's make that a less than sign. Yes, let's make that a less than sign. So now let's pick a test point. We can pick the test point of 0, 0. 0, 0 is not on the line, so we can pick it. Let's plug it into here. So 2 times 0 is 0, plus 3 times 0, which is 0, and less than negative 12 is 0, less than or equal to negative 12. I don't believe that's true, so then we shade above the line. And if we shade above the line, from the first two inequalities, we know we're in quadrant 1. Don't forget about those first two inequalities because the cutoff is right here. The y-axis cuts it off. And then we have a cutoff here and here. And that's where all 4 colors are overlapping. If you look right there, there's all 4 colors. And so we go ahead and shade. There's no reason to stay on the graph because it extends on and on forever, or as far as you want to go. And so typically we just always stay on the graph, but I'm just letting you know it doesn't stay on the graph just because it's the only part you see. It keeps going on and on forever. And so the blue part there that we have shaded in, that is the solution to that system of linear inequalities. And that wraps it up for today. That should wrap up your review on system linear equations and inequalities. And so you should be ready for your for whatever comes in the future for you. So if you have any questions, let me know, and we will talk to you next time.